Hi, and welcome to Section 3, Spawning Your Character. In the last section, we scripted health for our characters and added on-screen sliders to provide a visual representation of the in-game health status. In this section, we will examine loading and saving game data. Specifically, we will look at character settings to include preferences and game data. We will also demonstrate how to spawn our player character after death. Now we move on to the first video of this section and cover saving character settings. We will go beyond the simple notion of saving difficulty level, screen resolution, and other player selected settings. In this video, we're going to look at the two basic types of game data and the two primary methods for saving and loading game data. We will demonstrate both methods. When we consider game information we want to save and load, we are really talking about persistent data. That is, data that we want to persist between levels or between game sessions. Imagine playing a game for an hour, collecting coins, weapons, and earning experience points. When you resume the game the next day, you want the game to remember how many coins you collected, what weapons you found and purchased, as well as the experience points you already gained. This is persistent data. We can look at persistent data as having two types. The first type is game-specific. That type of data does not change and is persistent in each gameplay session. For example, the grass is always there, the rocks and mountains are in place, and so on. Of course, most games have randomness, but all the non-editable components of the game are considered game data. We do not need to do anything specifically to make this data persistent. So let's turn our attention to user-specific data. User data can consist of a lot of very specific information depending on your game. You might, for example, simply want to keep track of health, player progress, and high score. Or you might have a very detailed mission system with multiple objectives that you have to keep track of. You might also employ an elaborate inventory system and experience system. Now that you have the basics down regarding persistent data, let's look at how we can save and load that data. There are several ways that we can load and save data for persistence. We will cover the easiest and the most common. First, Unity provides us with a player prefs class that is relatively easy to use. As you can see by the sample code, we can call a specific player preference using the playerprefs.getInt method. Setting the data is equally as easy. We merely need to use one of the playerprefs.set methods. These methods are setInt, setString, and setFloat. One of the great things about using player prefs is that we do not need to specify a file name or location for the saved data. When we are developing for different platforms such as Linux, Mac OS, and Windows, this affordance is appreciated. The problem is that this data is not secure and saving and loading operations are inefficient. In addition, we cannot go beyond the basics in the types of data we store without adding complex scripts. Now let's turn to a more common and robust solution for loading and saving data in our Unity games. Extensible Markup Language, or XML, is the most common method of storing persistent data in text form. There are different approaches to implementing XML. The one we will use is data serialization. With serialization, we can save complete game objects from memory to persistent storage. As you can see here, we have additional packages we need to import. Here we have a class called SaveData, which we can use to store selected game data. At the top, you see the required import statements. Next, we identify SaveData as our file name and XML as our file format. You can see that we are using system.serializable on line 10 to tell Unity that our script can be serialized. That is really just a fancy way of saying that we can save the variables in this script. Next, we create a data structure to contain the rotation and scale of a given object. The next part of our script, starting on line 24, is our enemy data class. We created two data components, one for the data transform and the other a Boolean to indicate if the enemy is armed or not. We have a player data class to store the player's transform. We also have the SaveData class, which contains a list of enemy data, as we are likely to have more than one enemy character. We also have a player data object. The last two sections of the script are the save and load methods. You can see that the file name has been identified as saved data and it is in XML format. These methods demonstrate how to save and load XML serialized data.